This video is in response to a question about using the chi-square distribution to find the confidence interval for estimating a population standard deviation. So we're going to do that now. Okay, so this problem gives you a data set of 12 pieces of information, and they represent the age in weeks at which babies first crawl. So we're told the data is normally distributed, which is a requirement to be able to use the chi-square distribution, and we're given the sample standard deviation. We're asked to construct and interpret a 99% confidence interval for the population standard deviation of the age in weeks at which the baby first crawls. So here we are. This is our data, and we open it up in StatCrunch. So estimating a population standard deviation confidence interval given a set of data. What we're going to do in StatCrunch for this scenario is we're going to go to Stat and then Variance Statistics, and we're going to choose one sample. We're going to say with data. So our data is in this column var1. It's not grouped by anything. And we're going to do a confidence interval. And this one is at a level of 99%. And so this is the confidence interval for our population standard deviation, which is not sigma squared, it's sigma. So you have to pay attention to that for this problem, and that is that what we're calculating here is variance, and what we're asked to calculate is standard deviation. So I will get to that in a second. We can go ahead and show the critical value, though we don't need it, and then hit compute. All right, so all these values they're giving us is variance and not standard deviation. So it's important to remember how they're related to each other, and I'll just type it here to remind you that the variance is equal to the standard deviation squared. So, for example, if I take the S that they gave us and I square it, I will get the sample variance instead of the sample standard deviation. And the value for that, 9.810 squared, is 96.2361. So when we look at our StatCrunch output, it makes a little bit more sense. So here we are. Our sample variance is 96.24. It's slightly different here. Probably because of rounding error in what they gave us. So the degrees of freedom, remember, is n minus 1. So since we had 12 data points, our degrees of freedom is 11. These are our critical values for the chi-square, which we don't need. What we need are these lower limits and upper limits of our confidence interval, but these are the variance confidence interval. So the lower limit is 39.566194. But if I want to know the lower limit of our confidence interval for our population standard deviation, then I need to use a calculator and do the calculation by taking the square root of that. So we're going to do 39.566194 and take the square root. So 6.2901 is the lower limit of our confidence interval. You do the same thing for the upper limit, and that gives us our confidence interval. I hope this helps you with this problem.